Awesome, thank you. All right, so I'm gonna talk about near future, which is 1559 upcoming. This is joint work with Kristof from Nethermind. And let me also say that this is very much a work in progress. This is hopefully we'll have a write-up of this soon. So perhaps some of you already thought about the question of MEV in 1559, and the first conclusion one might arrive to, there's nothing new under the sun here. We're gonna burn the base fee, but there's no new MEV extraction opportunity that's raining on us. So it's nothing really strange, but still we think there's some, so this is perhaps correct at order 0, but we still think there's some interesting things to be said about 1559 and MEV. So hopefully this serves to spark some further thought on this. So I only have 15 minutes and I already spent my talk index time. So it's gonna be 3 surprise topics coming. First one is on miner economics. So naturally, there's the question of, okay, now that they will be have less revenue after 1559, will they be incentivized to extract more MEV in particular in a nefarious way, like Charlie pointed out before? Is there going to be more reorgs and time bandits and so on? So, okay, this is an interesting question. First, we realize we need some better understanding of miner economics, actually. So the first question we ask ourselves is, will miners switch lanes? Meaning, will they be incentivized to switch to other blockchains after the reward cut? So we built a super simple model. I'm going to run through it to try to assess this question. This is an equation for profit. So the profit is just reward minus cost. There's some equations for hash rate. There's a total hash rate that's distributed between Ethereum and X, other GPU-based blockchains. After 1559, this looks, again, distributed between post 1559 Ethereum and some other blockchains, assuming the total hash rate stayed the same. And there's a revenue drop due to the burning of fees in 1559, parameterized by some parameter gamma. Then we state some equilibria here. We say like the profit per hash rate is the same in Ethereum and in other blockchains. Otherwise, it would be a non-equilibrium situation where miners would be switching, and another equilibrium holds after the London fork. So we plug in some algebra here. We do some rearranging, and we can find an expression for the actual fraction of hash rate that stays in Ethereum after the London fork. Let me say that this is, of course, a very naive model. It doesn't consider in particular the cost of switching or the fact that the revenues are denominated in different currencies and miners might have more or less trust in the different currencies. So again, this is a very coarse first approach to this question. But we can do some nice colored graphs. Here you see the fraction of miners staying in Ethereum after the fork as a function of the revenue drop after 1559. And we have another parameter, which is, again, the size of these other blockchains in terms of revenue for miners as in proportion to Ethereum's, right? So we can plug in some numbers here with actual data from the different revenues, the sizes of other blockchains, and we actually find that we're in the red cross there in the graph. It looks like most miners will stay in Ethereum according to this prediction. It's 0.98, so 98% of miners would stay. The equilibrium would be at 98% of miners staying. Of course. Again, these numbers are super tricky. They change by orders of magnitude. So you're all aware of how gas prices change. So this is, take this with a grain of salt. So, okay, this is for, again, the miner economics and switching to other chains. How does MEV play a part here? So first question that comes to mind is how much extra MEV miners will have to extract to match profits before 1559, and this is a whopping 150% more. So they would have to go through a lot of effort to try to increase their extraction widely to actually compensate for the drop in miner revenue. But of course, this might be like prohibitive, or it would be easy, of course, to try to come up with strategies to do that. So the next question is try to integrate the two things and compare this the extraction with the switching. So we can ask how much extra MEV would need to be extracted to match the revenue hike from switching chains. Okay, so to achieve this equilibrium, in achieving this equilibrium, they would increase their profits a little bit. What would that be compared to if instead of switching they would extract more MEV? And this is a more reasonable number of 22%. Of course, these numbers don't tell us what miners will actually do. It's not enough to think about these numbers in terms and try to come to conclusions, but it gives us a framework to compare the two different things that are switching to other chains and extracting more MEV. So we think it's a first steps to work. Next step would be incorporating costs more quantitatively and try to model that, and perhaps agent-based modeling and so on. So again, this is a first approach. Take it as a working process. So I think it illuminates a little bit the different ways of these two factors of the equation, the switching chains and the MEV one. Okay, the second topic I wanted to talk about is the fact that there's actually many auctions going on in Ethereum, despite the picture we have of running one auction for inclusion. So what 1559 was designed and mostly analyzed in a pre-MEV world. Charlie already gave a timeline for how MEV developed, and although the MEV idea was there earlier, the extraction was much less and was a fringe activity. Now we're in a world where this is commonplace. We have like Flashbots auction all the time, but what happens here is that this design assumed there was an auction, that the Ethereum auction was for transaction inclusion in blocks, while in reality we know that users bid for much more than that. They also bid for ordering of transactions, they bid for privacy and so on. So how does this change things? So in particular, I'm going to focus on Tim Raff-Gardner's analysis of 1559. So he posits three things that are desirable from a transaction fee mechanism. The first is the myopic miner incentive compatibility, saying that miners are incentivized according to the mechanism in the first place, in the short scale, one block. Second is user incentive compatibility, meaning they achieve the desired UX improvement of users expressing their true preferences for inclusion without needing to strategically speculate on what other users are doing. And off-chain agreement proofness, meaning that users and miners cannot outgame the system by making agreements outside of the chain. So he shows that MMIC and OCA proof are satisfied by 1559, but the UX improvement is only achieved outside periods of high demand. In that same paper, he posits another alternative possible mechanism, which is the tipless mechanism, which he shows to be myopic miner incentive compatible, user incentive compatible, and only OCA proof in periods outside periods of high demand, right? So here we're left wondering, okay, right now we know that OCAs are commonplace these days via Flashbots, for instance, for ordering of transactions. So perhaps having a tipless mechanism would have been a better idea, like where users are all the time guaranteed that they don't have to speculate on other users' price setting when they only care about inclusion, and separate the auction for ordering. Right, so again, this leads us to think, okay, there's this many auctions going on. Perhaps we could think of the inclusion one as like optimized for user experience, and have the ordering one be done elsewhere. In particular, we have, like already mentioned this, we have the inclusion auction, the privacy, the ordering one, all like handled at different levels, if you will. We're in fact at Flashbots starting to discuss tiers. Okay, some searchers care about ordering, but perhaps regular users only care that their trades are not front run, so they only care about privacy. So should we treat this separately? And in fact, if you look at traditional finance, they run different markets for different instruments. There's one for stocks and one for options, and these are all these are all separate places, so they can be more efficient. And if you look at our auction, it looks like it's perhaps more attuned to ARBs than liquidations, and there's like due to our pricing formula, and this is all open, and you can look at this formula in our documentation, and there's discussions in the GitHub. But so this leads us to the greater question of, can we efficiently encompass all preferences with a single auction? And here the key word is efficiently. Again, this is many things going on at once. Can we make it in a way that it's efficient for all the interests there, for all the users? And yeah, so this is one of our key research problems. So if you're interested in that, please come talk to us. And yeah, now that MEV is commonplace, more generally, we need earlier involvement with the EIP process. I'm happy to say that we're thinking a lot about ETH2 and how MEV will interplay with ETH2. All right, final topic of my session, it's on Flashbox ethics. So ethics is something that was on our research agenda from the very beginning. It's really critical for us to be transparent. And in particular, right now, 85% of the Ethereum's hash rate is running our software. So it's a new shelling point. And by this, I'm thinking about a situation where miners could passively collude by just adopting Flashbots default. This is not different from like the situation before where Geth was this shelling point, but now that we have that responsibility, we will be open about it and think about the implications of that. And here I'm thinking about within protocol collusion, so nothing like 51% attacks or something like that, but instead, to give you a concrete example, think we have in MEV Geth a parameter that's the max merge bundles. So it's a parameter that says how many maximum bundles can be merged in a block. And so could we with Flashbots lead to having only bundle blocks, so no vanilla transactions by playing with these parameters and feeding something to the miner? So this is clearly not feasible because there's opportunity cost of eventually of leaving transactions out. So this comes back to the first slide there, where there's really nothing new here. But this brings yet another question. So it doesn't seem like Flashbots is more powerful after EIP-1559, but can Flashbots defeat 1559? And to wrap up my talk, I'm gonna show you some ideas along these lines, or one idea along these lines rather, which is, what if Flashbots by default decided to fill blocks only up to a size slightly smaller than the target block size S0, right? So we can actually simulate this, again, assuming 85% of the hash rate is doing this instead of what's meant to be filling up to S0. And this is what we find. This is the base fee as a function of the time for different values of this epsilon parameter for some demand dynamics. This is based on notebooks by the robust incentive group at the Ethereum Foundation. So you see here that if for some value of this parameter, if all miners run this modification to the software, they would be able to drive the base fee to 0. Of course, the question is this tenable economically, right? They would be forfeiting a profit, immediate profit. In the long run, this would be good because they would have there would be no burn fees, so it would be all tips, thing they can get revenue out of, but it will be in the short term unprofitable because they would be leaving transactions out. So what is the critical number of underfilled blocks for this to turn a profit for miners? Okay, and this is the part where it's a work in progress. This is unfinished work, so hopefully we'll have an answer for this question soon. And it's important to think about this question for how 1559 will ultimately have an impact on the network. So stay tuned for an upcoming post on this. Again, this is joint work with Kristof Gazso, and thank you all the people that contributed to this conversation, Barnabé Monod and the Robust Incentives Group, Tim Bako, Leo Zhang, and of course the entire Flashbots crew. All right, thank you all for tuning in.
All right. Thank you, Alejo, and you made it perfectly in time.
Yes.
So Do we have any questions from ETHGlobal.tv live stream for the speakers? If not, I suggest the speakers who just finished speaking can sign in to ETHGlobal.tv, where you can directly interact with our audience on the live stream.